Okay, so we're going to be doing the Check Your Understanding for topic 5.5, which is the candidates test, or the way to find absolute extrema. So when you're asked to find the absolute value, you're doing the candidates test. That absolute max or the absolute min, you're doing a candidates test. At which values does this function have absolute max on the closed interval from -2 to 4? So because it's a closed interval, there is an absolute max and there is an absolute minimum, period. It's not true if it's an open interval, by the way. Anyway, so f of x. So we're going to start by taking the derivative. 3x squared minus 6x. Set the derivative equal to 0. Factor, we're still by factoring out 3x, leaving behind x minus 2. So my critical values are, critical points are x equals 0 and x equals 2, both of which are in the interval. I need to check the entire interval, so I'm going to check x values of -2, 0, 2, and 4. And I'm going to plug them into the original function. So sometimes what I get confused about is what am I checking? Am I checking in this or that? The other thing I can do before doing this is I can throw out which one of these is a minimum. I'm not going to bother this time, but sometimes it's nice and you can throw one out and say that's a min, doesn't matter. So we'll start with 0, 0 is 12. I can plug 0 in really fast. 0 is 12. -2 is going to give me -8. Minus 12, which is -20. -8 minus 12 plus 12, so -8. 2, 8, minus 12 plus 12, so that one's 8. And 4, 64 minus 48. 16 plus 12 is 28. So my value, absolute max, wow. At x equals 4 of f of 4 is 28. Okay, so the max value occurs at x and is the y value. So that's a little tricky there. Okay, next. Number 2. The graph of f prime is shown below. The graph of f prime has horizontal tangents at x equals 3, x equals 2, and x equals 5, and a vertical tangent at x equals 3. So this is a graph of f prime. Very important to notice what is being graphed. So this is f prime. Okay. So horizontal tangents meaning that the horizontal tangents mean that f double prime is equal to 0 at x equals -3, f double prime is equal to 0 at 2, and f double prime is equal to 0 at 5. Okay, so because there's horizontal tangent, and the second derivative is at 3 is undefined. Okay, so that's important. Look at that. List the candidates for the absolute max of f of x. So the candidates for the absolute max, not of this, but of the original that we don't see, occur when the derivative is equal to 0. Okay, and the endpoints. So the candidates are x equals -7, -5, -1, and 5, and 7. Now, one of these is not, 5 is not either. 5 is neither. So these are the critical points. Let's go up here. Critical points are -5, -1, and 5. Those are my critical points. And we don't know where the original is undefined because we know where f of prime, where the second derivative is undefined. Okay, so anyway, those are my critical points. This is neither in min or max. Because the signs of f prime do not change. Because it goes from positive to positive, so the signs aren't changing. So that's not a candidate for the absolute max. So we throw it out. These two, so this one has a positive slope going to a negative slope. And so that is a max. This one is a negative slope going to a positive slope, so this is a min. So I'm going to throw out -1 because it's a min. So this one's a min, this one's neither. That one's a max, and the endpoints are always candidates because we don't know. So those are our candidates. Let me just kind of clean that up. X is -7, -5, or 7. And 7 and -7 are endpoints, so they're always included. And -5 is a relative max, so it's included. So going for our candidates for the minimum then will be x equals -7 and -1, but not -5 because -5 is max. And 7, and again, plus and -7 are endpoints, and x equals -1 is a relative min. Now, why did they tell me this if I didn't need it? Why did they tell me all that stuff if I didn't need it? Oh, wait. Where the derivative is undefined. Derivative is defined, just kidding. Okay. If they had said, find the candidates for the absolute max of f prime, they're there. Those are the candidates for f prime. Let's go with it for extrema of f prime. So be aware of what it's saying. They were absolutely trying to trick you that information, but on an AP test that will be there. So if this is a free response question, totally like a free response question, they could be asking, one would be asked about the f, one would ask about f prime, and you have to be really careful. And so that's why that's there. Okay. So even though we didn't need it, it's there because of that. Last question. Position of a particle is given by x of t equals e to the -t. Blah, 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 blah. Find out which time this particle is furthest to the left. So when we talk about a particle moving from left to right, left is negative, right is positive. We already know that kind of stuff. But the idea is that the furthest to the left will be a min. So furthest to the left is a minimum. If it said furthest to the right, we'd be looking for the max. So it wants to know the furthest, so we're looking for the absolute min. Okay, so start with the derivative. X prime of t equals first times the derivative of the second plus the second times the derivative of the first. So it's e to the -t times the derivative of -t, which is -1, which is kind of makes sense. Okay. When z equal to 0? Well, let's clean it up a little bit. Negative e to the negative t cosine t minus e to the negative t sine of t equals 0 when these are equal to each other, sort of, but go with e. T sine of t equals negative e t cosine t. Now e of t and e of t are always equal, so I'm going to go ahead and remove them. Okay, and it won't be divided by 0 because e of t will never be 0. Go ahead and take those off. And I'm left with, where is the sine of t equal to the opposite of the cosine of t? Now sine and cosine are equal at pi-fourths. So if we remember that, remember our unit circle, sine and cosine are equal at pi-fourths. And so that's in the first quadrant where they're exactly the same, and in the second quadrant, third quadrant where they're exactly the same. In the third and fourth quadrant, they have different signs at the pi-fourths. I can't remember what it's called, reference angle. So I need 3 pi-fourths because that's over here, and 7 pi-fourths because that's down here. And so t equals 3 pi-fourths and 7 pi-fourths. Those are 2. And we're going between 0 and 2 pi, so that's good. We just need the basic unit circle because that's when they're opposite each other. So these are our 2 critical points. And so now we need to do a test. And it looks like I'm going to need some more paper. So I'm going to do a candidates test. T. Endpoints, 0. Critical points, 3 pi-fourths, 7 pi-fourths, and another endpoint, pi-halves. Now again, if I check, I can throw which one of these is the relative max. But I often just don't bother. It's easier just to go for it sometimes. So f of t, so now I'm plugging, x of t, I'm plugging into x of t. If I can find the name of the thing. So x of t. So I'm going ahead and plugging into x of t. What I plug in 0. E to the 0 is 1. Sine of 0 is 0. So this one is 0. 2 pi. E to the negative 2 pi, whatever that is. And sine of, it's a very small number by the way. And the sine of 2 pi is 0. That one's also 0. Okay. Just making sure my brain. Yep. 0 and 0. So then I have e to the 3 pi-fourths negative times the sine of 3 pi-fourths. So I'm just going to leave this one as e to the negative 3 pi-fourths. I know it's a positive number. That's all I know. Sine of 3 pi-fourths is, of course, radical 2 over 2. We're in this quadrant, sine is still positive there. So that's a positive number. Then on down here we have e to the negative 5 pi-fourths. And then the sine of 5 pi-fourths equals e to the negative 5 pi-fourths times negative radical 2 over 2. Because it's radical 2 over 2, but I'm in this quadrant over here, the fourth quadrant, and sine is negative down here. So this one is smaller than that because this one's negative and that one's positive. Because remember, e to the whatever is always positive. Always positive. Doesn't matter. Negative number just means it's really close to 0, but it's still positive. So now this is a negative number, and that is a positive number. So we were looking for the furthest to the left, and that occurs. The particle is furthest to the left. at t equals 7 pi fourths. And our justification is that x of 7 pi fourths equals negative radical 2 e to the negative 7 pi fourths, whatever that is. Make sure that looks like e to the negative. Okay. Because that's a 0. This is a positive number, that's a negative number. This is the max, that's the min. That's it. All right. I'll talk to you guys soon. Have a great day.